geometric series, what's that mean I want to do? I want to, yes. I want to get the sum of the terms here going again. So, yep, we got to come up with another formula. And this is kind of, if you remember the other day, to show you how I got the sum formula in arithmetic, I wrote the terms in reverse order so that they all added up to the same number. Okay, this one's got a trick to it too. I'm going to do a nice, relatively easy series here. What's the ratio in this series? 5. We're multiplying by 5. Okay, and just so we can be sure that this is right, this one's really easy. If you add up from the back end forward, what's it add up to? That's right, so it adds up to 312. So we know that's the answer we're supposed to get when we do this mathematical magic. Okay. In this case, what I want to do, I'm not going to write them in reverse order. This time, I want to times that sequence I just wrote times the ratio. So I'm going to take, in this case, the ratio is 5. I'm going to take this whole thing times 5. And I'm going to choose where I want to write those numbers, though. So if I take 2 times 5, I will get 10. But I choose to write it over here. If I take 10 times 5, I'm going to get 50. 50 times 5 is going to be 250. And then 250 times 5 there you go, 1,250. Now, this time I choose, I want to subtract them instead of add them. Okay. What is 1 sum minus 5 sums? Negative 4 sums, yes. All right. Now, you're subtracting. 2 minus nothing below it is 2. 10 minus 10, gone. 50 minus 50, 0, that's gone. 250 minus 250, that's gone. Okay, what do I do with the 1250? Yeah, because it's like it's 0 minus 1250, so there would be a minus 1250 out here. So by doing that, I just made all those middle terms cancel, which is pretty sweet. I just ditched all the middle, and I've only got these 2 terms left. Well, if I combine those, 2 minus 1250 is really, yes, negative 1248. And then, if I choose to divide the negative 4, you will discover that you get 312. The solution we knew we were supposed to get. So now, how do I turn that into a formula? 5 is the ratio. I chose to multiply by the ratio. Okay. So now, translate this. To get the 1248, the negative 1248, we did 2 minus 1250. Where did 2 come from? That was the first term. Okay. I subtracted. Where did I get 1250?
The last term times by the difference.
I'll buy that, except I'll change it to the times by the ratio. Yeah. So the last term times the ratio gave me 1250. I ended up dividing by negative 4. Where did negative 4 come from? It was 1 minus what? 1 minus the ratio. So you divided by 1 minus the ratio. And ta-da! There is your formula. Okay. The good part of geometric series is the formula will solve it. You'll never have to go to another formula to get something you need. You'll be able to fill the correct information into the formula and get the answer in one step. You won't have to work 2 problems to get to this. So that's the good news on that one. Problem is, though, there's actually 2 sum formulas. Because I can take this formula we just created and put a slight alteration in it and get a second formula. So all I'm doing here is a little bit of algebra. I'm taking that formula, but in place of the a sub n, don't we have a formula over here for what a sub n equals? And you're going to think, oh, but this makes it terrible. She's making horrible stuff in there. Because I'm putting in place of a sub n, I'm putting that whole a sub 1 times r to the n minus 1. And then up here on this formula, it's still times this r on the back end. And you're thinking, that doesn't look better. Okay, question. Does a sub 1, first term minus first term, cancel out, make 0? Can I subtract those?
Oh, no, you have the multiply.
Yeah, order of operations says I'd have to multiply first. You cannot cancel those! This formula, you're going to be stuck with a first term minus a first term. Those don't ever make 0. You can't do it. It's multiplied. What I can do, though, I'm going to be stuck with first term minus first term. I can combine the r's because they're being multiplied. When you multiply variables, you add the exponents. What do you get when you add n minus 1 plus 1? You get n. The 1's cancel. So this would be times r to the n, and you leave the 1 minus r. There's your second version of this formula. The big question is, how do you know which formula to use? Each one has one thing in it that's not in the other formula. Up here, this one has an a sub n in it. So if you know the last term, if they give you the last term, you use that formula. Okay, what is down in this second formula that you don't see in the top formula? It's got, the r is the same, it's actually just the n. What does n stand for? Yeah, it's the number of, I wrote that wrong, it's the number of terms you have. So if they tell you you're doing 10 terms, then you know n's 10. So you choose your formula based on what the problem gives you. If it gives you the last term, you choose the top formula. If they tell you how many terms you're going to have, you use the bottom formula. If you let what's given in the problem tell you which formula to use. They both work fine, they both give you the same answer. So, I can use my poster that I ripped. Last term, number of terms. Okay, do you have to know these formulas come Monday? I'm giving you the formulas. You don't have to memorize formulas. That's too confusing. That's too many formulas with too much stuff the same. No, I don't expect you to memorize those. I know them because I taught them for years and years and years. You all aren't going to know those formulas. I don't expect you to memorize that. You get seriously into a math field or an area where you have to do sequences all the time, okay, you'll learn them, but most of you aren't headed that route, probably. Although I heard a thing on the radio the other day that said the top 4 jobs, they just did another study, top 4 jobs, of the top 4, 3 of them were math-related jobs. And the very top most best job was to be a mathematician. Yeah. Now, you all have to understand, mathematician does not mean person that's sitting at a college teaching mathematics or something like that. This means you are a mathematician employed by some company doing research for them, and you're doing the mathematical side of their research. You're inventing new products, new ideas. Mathematicians actually have applied knowledge they use in the real world. So, I'm willing to bet that actuary was in those top 4 too, but they didn't list all of them on the. What was the worst job to have? Lumberjack. Highly dangerous and doesn't pay well, evidently. So that was the bottom job to have. So there you go. Don't be a lumberjack. All right, we need to be a touch speedy here because I have to show you the quick way. We have to add them up infinitely yet. But before I do that, let me see if you could follow a formula. Okay, this particular sequence, it starts at 624 whatever, and it ends at 6,291,456. Or 291,000, sorry. I can't write. Come on. 2, 9, 1, 4, 5, 6. So, that is the what? That is the last term. So therefore, do you know which formula to pick? Yeah. You know the last term, so that screams at you, hey dude, use this formula. If I had said sum this out to 10 terms, you would use the bottom formula because you know you're using 10 terms. So My most missed thing when you take this quest on geometric series, the number one mistake I see on these, people have it entirely set up right on their paper and punch it in their calculator wrong. The number one mistake. So, do show me your work, that's important. Alright, so start telling me, what's the first term? So this one is supposed to be 6 minus, eighth of n means I should fill in the last. So 6291456 times the ratio. Is this an easy ratio? Looks to me like it's times them by 4. Over 1 minus 4 then. And you go to your calculator, you punch it in, and you're done. This one comes out 8,388,606. That's a sum. Imagine if I let it go to 20, 30, 40 terms, how big these puppies could get. At some point, we could max out your calculator memory. All right, now you're going to be excited to see this because I know you all love these O's so much. You can do summation notation with geometrics. Okay. What is different about that formula from what you saw when you did arithmetic problems? There's an exponent there. Your arithmetic problems might have been something like 4k plus 3. Okay. So how you can spot a geometric? It's got an exponent. If it's got the exponent, you know you're looking at a geometric problem. Arithmetic are always multiplying a number times the variable. A geometric will have the variable up in the exponent. That's the difference here. Okay, on the arithmetic, which number was going to be the difference? Which number is how much it's going to go up every single time? The 4 or the 3? The 4. The number you're multiplying by your variable. Every time the variable gets bigger, you multiply by 4. It gets 4 bigger. So that number is always the difference. Okay, so then think about it. On the geometric here, which number is going to always be the ratio? What's going to make you multiply by the same number every time? The 3. Because if you make your power go up 1 each time, if the power goes up 2, then 3, then 4, aren't you just going to multiply by another 3? So, yeah. So your ratio is always that base number. Always. Ratio is the base number. Okay. This is totally your pick. Both of the sum formulas work. You can use either one. It's a matter of which one makes more sense to you. So you can do the last term, or you can do the number terms, because you know, or you can find both things on there. It really doesn't matter which one you pick. The only thing I'll say is, sometimes the last term, if the ratio is a fraction, sometimes the last term can be a really icky number. Whereas, you know, n, the number of terms, is always going to be a whole number. But otherwise, it really doesn't matter which one you use. So pick one. Which one do you want to use? First one. So if we're doing the first one, I have to be able to fill all those things in to sum this baby up. I assume you don't want to write out all these terms and add them up yourself. Hold, you said first one. So how do we find first term on here? It's the exact same thing you did on arithmetic. How did you get the first term? Oh, well, you're right. Oh, wow, that's really bizarre. Okay, try that. Okay, we'll try again. So, how did you get the first term on your arithmetic? You took the 2, yeah, and you put it in for your variable. So, first term is going to be 7 times 3 to the 2 minus 2 power. Well, 2 minus 2 is 0. What's anything with a 0 power? 1. So 7 times 3 to the 0, that's 7 times 1, or 7. So ta-da, you know first term is 7. Last term. Last term, you got to take the high number and put it in. So if I'm going to do last term, I'm going to go, what's 7 times 3 to the 9 minus 2 power? Oh, wow. See, this is why this is not always my favorite formula. I need help because I don't have this answer done this way. I need to know what 7 times 3 to the 7th power is. It's going to be a pretty good sized number. $15,309. So, okay, that's your last term. How do you get your ratio? It's the base number. Ratio is 3. So it'll be over 1 minus 3 then. And get out your calculator, it's your friend. This actually doesn't come out as horrible as it looks. It should come out 22,906 or 960. So, really isn't all that terrible once you figure it out. Alright, last but not least, dudes. Let's see if I can start a fight, and I have 4 minutes to have this fight. Suppose I gave you this one. And I said, add it up going forever. Let it go infinite. It goes on forever. What's the sum? Well, what's going to happen is you sum that up. Joel says it's adding up to infinity, because it's just going to get bigger and bigger and bigger and bigger. And you're right. It is. It's going to add up to infinity. Okay, in the math world, when something goes up to infinity, we say it diverges. And yes, that probably relates to the book and the movie. I've read the book or seen the movie, so I can't tell you why divergence and diverge would go, but I'm sure there's some commonality in the terms. Okay, notice, what was your ratio on this problem? 2. Okay, now, watch this one. What's my ratio on this one? My ratio is a half. Okay. If I actually start summing them, 4 plus 2 is 6, plus 1 would be 7, that'd be 7.5, add a 4th, that'd be 7.75, the next one would be 7.875. Is it going to go to infinity? Do you think it's going to go to 8?
No, it's not.
It's not going to 8?
It's like 7.9.
Okay, but the key thing is, it doesn't go to infinity. So therefore, it has a sum. We can actually find that sum. If it's going to have a sum, we say it converges. So it does not go to infinity. Okay, how can you tell? By just looking at the series, how can you tell whether it's going to diverge or converge without ever working anything out? Yeah, it's all in your ratio. If your ratio is a number bigger than 1, doesn't matter if it's positive or negative. If it's a number bigger than 1, it's going to diverge. It's going off to infinity. But if your ratio is a fraction, somewhere between 0 and 1, it's going to converge. So all you have to do is look at your ratio, and you can tell. Is it going to go to infinity? Is it going to actually go to a number? Now, since I have 2 minutes left, you're going to get the shortened version of this. All it does, the formula actually for this is super simple, because all it does is it takes this formula we already have. In this problem, my first term's 4. No, 2 seconds. My ratio is 2, and if I'm going to infinity, but actually I need to be doing a fraction. What happens to a fraction if you take it to a whopping huge power? It's smaller. It's 0.0000000. So this whole thing is going to go towards 0. What's 0 times 4? 0. That whole part wipes out, becomes 0. So if you want to sum an infinite one, it's just first term over 1 minus the ratio. That's all you have to do. They're the easiest problem you ever work. So actually, Brianna, you said it wasn't going to go to 8? That's exactly where it's going to go. 4 divided by half. The sum's going to end up being 8 on this problem. Then there's a whole theory of math we could go crazy on about all that, but